Come also to our prayer. Heavenly Father, I want to thank you for today. We thank you that we are here for yet another lesson of chemistry. May you help us understand. May we understand everything that's going to be taught, and may the lesson go on smoothly. In the mighty name of Jesus Christ, I prayed. Amen.
Amen.
Okay, you're all welcome. Thank you for joining the lesson. We're going to do a simple recap of what we looked at last week. I think we looked at how we can identify the purity of different substances, and we mentioned some few methods. Can someone remind us which methods we mentioned during that lesson?
Hey, I need to.
Yes, let's have our before, sorry. Unmute and tell us.
One of the methods was finding the boiling point. Sorry. So the first experiment, we did an experiment of finding the boiling point, which was a way of finding the purity of the substance. Then the first method was by heating the liquid directly using a heat source. Then the other one was heating a different liquid to heat the one whose boiling point you want to find.
Okay, thank you. That was beautiful. Let's have someone else with a different answer. Let's have Charity unmute. Charity.
Excuse me, teacher. For me, I just to ask if you can help and send notes for the last lesson. Excuse me, teacher. Help and for the last lesson on Google Classroom.
Okay. Let's have Atkunda unmute and tell us.
The other ways were by finding its melting point, the refractive index. Yeah, that's what I got.
Okay, beautiful, thank you. Okay, so today we'll be looking at melting point. And I'll request someone to define for us what melting is. What does the term melting mean? Yes, Ario, you can unmute. Ario, you can unmute. And
I wanted to ask a question.
Okay.
How does the presence of impurities affect the boiling point of water?
How does the presence of impurities affect the boiling point of water?
Yes.
Okay, can we have someone answer Ario? Because I remember we discussed that in the previous lesson. Can we have someone to answer her? Yes, Chirabo, you can unmute.
Impurities increases the boiling point. Okay, thank you. Welcome.
Thank you, Chirabo. Okay, I think we can go ahead. Let's have Marjorie unmute and say something.
Melting is the point where a solid like ice turns into water.
Sorry?
Melting is the point, it's a point where ice turns into water or a solid turns into water, like ice.
Okay, Is it really a point? Thank you both for that answer. Let's hear from Achkunda Vanessa. You can unmute.
Melting is the change of state of matter from solid to liquid.
Okay, that is beautiful. Thank you. So last time we looked at boiling point as one of the ways we can identify the purity of a substance. So today we shall be looking at how melting point helps us determine the melting point of a given solid. And we have various used during that process. We have ice, we have naphthalene, and very many others. So I'll briefly take us through the process. I hope Mr. Crescent can help us project that diagram that shows us. Okay, thank you, Teacher Crescent. Yes, this is okay. In this case, we have an experiment showing us the determination of the melting point of ice. And in this case, we know that ice is our solid. So we place ice in a beaker, insert a thermometer, as you can see. And I guess we all know the use of the thermometer. Then the glass stirrer, which will help you in stirring during the heating process. Realize that there is a heat source, which is the burner that is helping us in the melting process of the ice. So you keep on stirring, and then as the ice melts, you realize that it will reach a given constant temperature at which it has melted. And then when it gets to that point, you note down the temperature of you note down the melting point of the ice. So that at the point where it has melted, you realize that the temperature remains constant for a given period of time. Can someone remind us what the melting point of ice is? Let's have Hosanna unmute. Nanyans, you can unmute. Okay, it seems she's off. Let's have Chirabo unmute.
The melting point is 0 degrees Celsius.
Right. Thank you. I see a lot of hands. I'm not sure whether there are questions or you want to say something. Okay, Charles, did you have a question? Maybe you can unmute and ask. Okay, Vicky.
Excuse me, teacher, can you please repeat the point of determining the melting point of ice? My network was unstable.
Okay. So on your screen, you realize that we have the experiment displaying how this melting point of ice is determined. You realize that we have a beaker in which you place your ice, because in this case, our solid is ice. And then you place it on top of the tripod stand. Under the tripod stand, you realize that there is a source of heat, which is the burner. So you place a thermometer and a glass stirrer. That glass stirrer is to help you stir during the experiment. And the thermometer, I am very sure we all know what it does. So the thermometer will help us to determine the melting point of ice. And as you keep on stirring, you realize that the ice will be melting. And as it melts, you realize that it will reach a point where the temperature is constant. So at that temperature, where the temperature that is constant for a given period of time will become the melting point of ice. And we've said the melting point of ice is 0 degrees. Okay, I can see another hand. Let's have Anna. You have a question, you can unmute.
Teacher, in the previous lesson, the teacher told us to the teacher left us with a question that says, why do we use indirect heating for some liquids and directly heat water?
Okay, we are getting there. Thank you for remembering, but we are getting there in the next few minutes. Thank you. Okay, we have a question under that experiment, and it says, how do you determine the melting point of a flammable solid? Can we have some answers? How can you determine the melting point of a flammable solid?
Maybe what's a flammable solid to start with?
Charity is ready to answer.
First of all,
Teacher, I think a flammable solid is a solid that you can heat and it melts. Then about how to determine the melting point of a flammable solid, I think you heat the solid and then you put the temperature in the beaker where it's being heated. Then the temperature that remains constant when the flammable solid has finished turning into a liquid is the melting point.
well, thank you, Charity. That was good.
Excuse me, teacher.
Yes, Charity.
I also wanted to ask what you were talking about when you said melting point of ice is 0 degrees, because I had gone off and that's what I found. So I didn't know exactly what you were talking about.
What we're talking about, I was just explaining how we can determine the melting point, and then I posed a question asking the melting point of a given, the melting point of ice, and someone told us it is 0 degrees Celsius. That is basically what we're saying. Paul, do you have something to say?
Yeah, I think a flammable solid is a solid that can catch fire.
Okay. Beautiful, thank you. 4%, I think we can move to the next experiment. So
No.
some of
yes. I'd like to just make a point of order. I do appreciate coming back as repeat for me will not stand. When you come in, just follow from there. The teacher will try to be as slow as possible. That's my request. To harmonize properly, a flammable solid is going to catch fire easy. If you look at that diagram, even if you leave ice, it will not catch, not flammable.
Okay, since we've lost teacher Eve, but she'll be back in a few minutes. But she was just trying to draw more light on looking at the flammable. Let's look at water. You notice that when you heat water, it cannot fire. That means you can easily use the direct heating. But there are some of those substances that they are flammable, they can catch fire, so that they cannot heat them directly. Like when you look at the experiment we have on your screen right now, you notice that we have a boiling tube that contains naphthalene inside a water bath. So you notice that we are not heating this substance directly in us. So you notice that we have the thermometer started into the naphthalene, and then boiling tube is started in the beaker, and obtain the naphthalene. You realize that at this point, we have the temperature of naphthalene at a constant point at a given time. Notice that this temperature will become constant, and at that point, that becomes the melting point of naphthalene. So we have a question on that same slide, which says, directly, like was that case? Explain why naphthalene was not heated directly. Who can tell us why?
You have some hands up to choose from.
Okay, let's have Maria Elizabeth.
Maria Elizabeth.
Teacher, to ensure that even heating process is carried out.
Even heating process is carried out. Okay, thank you, Maria. Can we have someone else? Jiwenji, you can unmute.
I think we don't heat it directly to prevent it from catching fire since it's being heated.
Okay. Thank you, Jiwenji. Let's have Nachagunde unmute.
I think to prevent the liquid from bumping out.
To prevent the liquid from bumping out. Okay, thank you. Let's have Dagano unmute. Dagano Queen Esther, you can unmute and say something. Dagano, we can't hear you.
I think the liquid will catch fire if you eat directly.
The liquid will
Catch fire if you heat it directly.
Okay, can we have someone else? Thank you, Dagano. Let's have Nicole unmute.
I think the liquid has a low boiling point. So if we heat it directly, it might evaporate before we get the melting point.
Okay, thank you. Let's have Charity lastly.
Excuse me, teacher.
Yes.
For me, I didn't hear the explanation about the experiment of melting point of naphthalene because you were breaking and I didn't get anything.
Okay. I was explaining that when you're looking at the boiling point of naphthalene, you compare the diagrams, they're a bit different. When we were looking at the determination of the melting point of ice, we had, I'm still breaking. Maybe your network is a bit not good. Are you getting me now?
Yes, we can hear you.
Okay. I was saying, when you compare two diagrams, you notice that boiling, we were determining the melting point of ice without heating. We had the beaker of containing on top of the tripod stand. When it comes to notice that you're placing your naphthalene in a boiling tube, and inserting the thermometer into the boiling tube that has a naphthalene, and then you place that boiling tube into a water bath. you realize that we are not heating the naphthalene directly, we are placing it in a water bath. So that is why I posed that question. And I say that the temperature will keep increasing. And at a point where the temperature is constant, that becomes our melting point of the naphthalene at a given time. So you realize that there is a difference between these two determinations, the direct heating and the indirect heating, where we have the naphthalene in the water bath. Then I asked someone to answer the question that is displayed on that same slide. Do you notice that naphthalene isn't heated directly like was the case for ice? So after noticing that difference, you tell us why you think naphthalene is not heated directly. And different girls gave different answers. So I saw your hand up and I was wondering whether you have an answer to that.
Okay, thank you, teacher. I can answer. I think that maybe when you heat naphthalene directly, it can overheat and hence giving a wrong melting point. That's what I think.
Okay, thank you. Let's have our default.
Yeah, for me, okay. Naphthalene is flammable, so if you heat it directly, it will catch fire.
Okay. So you realize that the reasons why we don't heat most of these substances directly, some of them may overboil and give you the wrong temperatures, or you find that some of them are flammable, they can easily catch fire, or you even find that we need an even temperature. That is why we place them in a water bath, because you realize that when you heat directly, the substance may as well just boil off very fast. But once you place it in a water bath or in a bath containing maybe paraffin or glycerol, you notice that you'll have an even temperature for the whole substance. Is that clear?
Yes.
Maybe if Eve has something to add, or teacher Crescent, we can move on.
Not at this time for me, unless
Okay.
Eve has something.
Shaiv, if you have something to say, you can kindly unmute.
I think we carry on.
Okay, I can see some hands here before we go into the breakout rooms. Can we have some of them? We have Nantale. Nantale, you can unmute.
Teacher, I just wanted to answer.
Okay.
Yes. My answer was naphthalene is flammable.
Okay, let's have Nachigude. Nachigude, your hand is up. Are you asking a question or you're answering?
No, teacher, sorry.
Once you finish answering, please put down your hand.
Okay, we have 3 more hands here. Let's kindly take them. We have Gabriela. Gabriela, you can ask.
Teacher, I was asking about the
About
the question. How to determine the melting point of a flammable solid. I didn't get it clearly.
How to determine the melting point of a flammable solid? Okay, but you understand what the term flammable means, right? Anna?
Yes.
So when we have a flammable liquid, we expect that if we heat it directly, it will catch fire. So that means we have to improvise and use another method, which is indirect heating, like the case we have in naphthalene. We realize that with naphthalene, we are heating indirectly, we are placing the substance in a water bath so that it will not cause a fire or explode or something like that. Does that answer your question, Anna?
Yes, it does. Thank you, teacher.
Okay. Then let's hear from Dagano.
Yeah, I was asking if paraffin is a flammable liquid.
What do you think?
Yeah, I think it's flammable, and I think you can't put it like in the beaker if you want to find the melting point of another liquid.
Okay, but remember when you're heating these liquids, they are not to the topmost part. And remember, you're not directly exposing them to what? To the heat. So when you're heating, you look at that water bath that we have on the screen. You notice that there is a level of water that we have at that point. So you realize that will not give it the ability to catch the fire. Does that answer your question?
Yes, teacher. Yes.
I want to make a comment.
Okay, Chai.
Queen, that is a very brilliant observation. Which means when we are choosing the liquid to put in the beaker, we will consider more than one thing. If it is flammable, it might turn out to be dangerous. So as you pointed out clearly, let's know, even if we want just one with a high temperature, we should make sure it's not flammable because we can cause accidents in the lab. As the teacher has said, you'd put in little, but still you've got to be careful. So that is a brilliant observation that you've made. Thank you.
Thank you, teacher. Okay, let's hear from Nakato, then we shall go into the breakout rooms.
Excuse me, teacher. I wanted to ask the first question.
You wanted to?
Okay.
Okay.
The question is,
I'm not sure if any of the teachers is getting better because she's kind of breaking. I don't think I'm getting her.
how would you determine the melting point of a flammable solid?
How do you determine the melting point of a flammable solid? Okay, I think we've looked at that. Let me have one of the girls tell us how we can find the melting point of a flammable. Okay, let's have Charity.
So how to determine the melting point of a flammable solid? You put the flammable solid in a test tube or a boiling tube. Then you put a thermometer in that test tube where the flammable solid is. Then you get a beaker and put their water. Then you place the test tube with the flammable solid and the thermometer in the beaker with water or the water bath. Then you heat. Then you put the water bath on a tripod stand, and then you use a Bunsen burner as your source of heat. Then you heat the water, then the water will heat up and it will also cause the flammable solid to heat up and it will melt, changing from solid to liquid, and the temperature that remains constant when the flammable solid has melted is the melting point.
Nakato, does that answer your question? Yes.
Teacher Mata, I suggest let them also look at help them understand better.
Okay.
It's the next.
All right, let's have the video talking about. Chaperson, you can have the video.
Determine the melting point of a solid substance. The melting point of a substance is defined as the temperature at which the substance changes from solid to liquid state. At this temperature, both the phases, solid and liquid, are in equilibrium.
Does the melting point is same for all types of substances?
No, it does not. A pure substance has a sharp melting point and it melts at a definite temperature, whereas an impure substance has a lower melting point.
It means determination of melting point is a convenient method to check the purity of the solid substance. How can we determine the melting point?
Let us do an experiment to determine the melting point so that you can understand it easily. Aim to determine the melting point of a solid substance. Materials required: thermometer, 100 ml beaker, tripod stand, stirrer, thin-walled capillary tube, heating medium, water or paraffin, wire gauze, etc. Procedure: powdering the compound and filling of capillary tube. A. The thin-walled capillary tube is sealed from one end by heating it on gas burner for a few seconds. B. The given compound is crushed and it is pushed in the capillary tube in powdered form. The tube is repeatedly tapped and filled by the compound. Fix the tube with thermometer. A. The capillary tube is attached to the thermometer. B. The whole apparatus is arranged as shown in the figure. C. The beaker in which the tube has to be placed is filled with paraffin or water. Heating the liquid bath. A. The liquid bath is heated gently with continuous stirring so that the constant temperature is maintained throughout the liquid using a glass loop stirrer moving up and down. As the temperature reaches near the melting point of solid, the flame is reduced and the temperature is allowed to rise gradually. Note the melting point. A. Note the temperature when substance starts melting. The temperature is noted again when the solid melts completely. The average or mean of two values gives correct melting point of the substance. Observations. Serial number. Temperature when solid starts melting, T1. Temperature when solidification starts, T2. Average is equal to T1 plus T2 upon 2. Result. The melting point of given solid is X degrees Celsius. Precautions. The sample solid must be dry. No air gaps must be present in the filled capillary tube. The level of the capillary tube and thermometer must be same. Maintain uniform temperature of the liquid bath.
Thank you, ma'am. We have understood the experiment very well.
Okay, thank you, Teacher Crescent.
I hope that was clear.
Yes, it was clear.
Sorry about the interruption. I couldn't admit people when the video is playing. So maybe They should take a screenshot of this as we go to the breakout room. But I see some hands are raised up.
I said we shall handle those issues when we come back from the break.
Okay. Teacher Eve, are you handling the breakout rooms?
Yes.
Okay. Thank you.
So ready? I think I'm ready to send people there.
All right.
Okay, we can go.
Is Teacher Martha with us?
Yes, but we can continue. There are some hands up, or do we go direct to our discussion?
Okay, since everyone is here, let's first listen to them, then we'll get the discussion.
Listen, we have a few minutes. Let's answer.
Okay, let's answer. Harmonize. Maybe we'll answer in the process.
Okay. The first question, Crescent, could you
share? Okay, let me screen share. Can we all see my screen?
Yes.
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 Okay, answer
Yes,
this question.
teacher.
Yes, teacher.
Nantale, you
Let's have Vanessa.
No, I can't see this.
For us in group 3, for number 1, we discussed that part A, it's a pure substance, and part B, it's impure.
So if you Okay, Vanessa, thank you. We give the part A, the answer you gave, and for part B, give us the reasons why you zeroed at those answers.
Liana.
Vanessa?
Yes. Teacher, I couldn't hear you. You were breaking.
Can you kindly tell us why you zeroed at those answers for part A and B?
Because a pure substance has a fixed temperature, and an impure substance, like their temperatures vary. Yeah.
Okay, that is beautiful. Thank you, group 3. Then let's move on to question 2.
Sorry, Teacher Martha, there was a miscall in that answer.
Okay.
The males at thick while the impure at a wide range. It's not that the pure one has a
I request the co-hosts.
Go to the next question.
So if I request that the people that are not speaking are muted by the co-hosts, because we are getting a lot of feedback. We can't get you cleared.
No.
Okay, let's proceed. Martha, can we go to our next question? Okay, can we have an answer from Kahuga?
Shall we on number 2 or number 3? Excuse me, teacher, I had gone off. So are we on number 2 or number 3? Sorry, you're breaking. I can't hear. Number 2 or number 3?
On number 2.
Number 2.
Okay.
Number 2.
Impurities can lower the melting point of the water, or they can increase the melting point of the water. According to Google, it shows that impurities can also lower the melting point, and at times they can melting point. So they can lower or increase the melting point of water. Yeah. You guys, has teacher heard?
Yes,
I think she went off.
I think she went off. And the Charity.
So all the
Charity.
all the teachers are off.
Yes.
Charity.
Hello. Thank you very much for you. Thank you very much for your answer. But we need we have two cases. Impurities cannot do two things at the same time. You've said it can increase the melting point, it can lower the melting point. No. We have to choose one part. If you remember that your teacher said that if it is boiling point strictly, boiling point increases when we add impurities. So if it is melting point, it cannot do both. It can either increase the melting point or it can reduce the melting point. Let me pick two more people, then we can get to the final answer. Kwagala, you unmute yourself and answer, followed by, yes.
Teacher, for number 3.
No, for
We
number
are
2.
talking about number 2.
We are still on number 2.
In my room, we said the melting point reduces. Okay, like impurities reduce the melting point of water.
Perfect.
Excuse me, teacher. I had an inquiry to make.
Yes.
The answer kind of confuses me. How do the impurities make the boiling point reduce?
Okay. Now what happens, when you have water and it becomes ice. I need us to imagine two cases. The first case is water is very pure. The particles of water in ice will be strongly attracted together. But when water is not pure, when water is impure and still it forms ice, the particles in that ice formed from dirty water, because of the sand particles in the water and the dirt particles in the water, the crystals formed from ice are not very strong. So the particles will not, those crystals formed will not be so strong. That means that for ice to melt pure water, because of the particles being strong, they will require slightly more temperatures. Then for ice from dirty water, because the crystals formed from dirty water, they are not very pure and they are not very strong, they will not require a lot of temperatures. So if it is clean water, you find that the melting point of ice, clean ice particles, is 0 degrees Celsius. But when it is ice particles from dirty water, it is like -2 degrees Celsius, -3 degrees Celsius, because the dirt particles made the ice particles weaker. When you continue studying, you say that bonds holding particles are weak, but you know that when crystals have dirt in them or impurities in them, they are weaker. When crystals are pure, they are very strong. Okay. Martha, are you back?
Thank you, Teacher Bennett, for ably answering that question. So basically, some of you are confusing melting and boiling points. You are using them interchangeably. When you have impurities, the boiling point becomes higher than that of a pure substance. When you have impurities, the melting point becomes lower than that of a pure substance, as Teacher Bennett has explained. So I think we should go on to the next numbers so that we can finish.
Number 3. Those who can answer number 3, raise up your hands.
Teacher, can you, excuse me, teacher, can you please repeat the answer for
Yes.
part B? For number 1, part B?
The substance.
Hope you will answer followed by number.
Okay. Number 3.
Chirabo, can you answer?
I answer number 3. As in group 1, and the answer we came up with was a liquid paraffin with a boiling point of 370 degrees Celsius. And the reasoning was because, like, when you start heating up the water and you have something lower than the temperature of the evaporating. So I think it's best to have a liquid that boils at a higher substance. That by the time it reaches 122.3 degrees Celsius, the liquid starts melting instead of the paraffin evaporating, or substance that has a lower temperature evaporating.
Teacher.
Yes.
My group, group 8, was we picked water because we believe, according to the last diagram you showed us, which was determining the melting point of, could you please show it?
What do you want me to do?
Could you please show the slide of determining the melting point of naphthalene?
Yeah, but you see, this question is different. Okay, I understand what you're saying, but here we are dealing with benzoic acid. So we cannot exactly use the information there, the wholesale.
Not the whole, we just agreed that since water has a lower boiling point.
Yeah. Oh, yes.
Since water has a lower boiling point, we feel like if you had put paraffin, then it would take long for the benzoic acid to boil. But if you put water, then it would start boiling. Like, paraffin would be like.
Can you please mute your mic? Let's have some etiquette, okay? Don't shame yourself. Teacher Bennett, can you help me with that person?
Excuse me, teacher.
Yes. Who is speaking?
Me, Namoli Yonia.
Yes.
I see 2 names of mine, but that's not my voice screaming.
Yeah, that person left.
Yes, I think that person renamed themselves as my name, but it's not me screaming.
We are noticing that the indiscipline is coming back. That is why we mute you and don't allow people to talk. We are sorry for that, Yonia. Let us quickly proceed.
Yes.
Even sometimes there are boys in this class.
Pardon?
Yeah.
At times there are boys in this class.
Yes,
Yes, they are there. We even have proof.
but now we've run out of time, girls, and the class number has really dwindled. Teacher Crescent, I'm requesting maybe we start with those questions. What do we do? Although number 3 has been answered, can we talk about them quickly so that we let the girls go? It's past time.
Let's give them the other questions as
Teacher, we never.
Teacher.
For number 3, we never agreed which one was right.
Number 3.
You answer, please.
Excuse me, teacher. For me, number 3, I think liquid paraffin is right, because you have to use and allow the benzoic acid to boil, because if you use water will evaporate before the benzoic acid boils and melts. So I think the answer is liquid paraffin, whose boiling point is 370 degrees Celsius, and the reason is to allow the benzoic acid to boil and melt, because if you use water, it will boil and evaporate before the benzoic acid melts. Yeah, that's what we discussed in our group.
Thank you very much for that, Charity. Maybe the heat you're talking about should come out clearly. What is boiling is the water. Since the boiling point of the water is 100, as you heat, when you reach 100 degrees Celsius, the water will boil and go into vapor. It will not give you the heat that is supposed to push the benzoic acid to 122.3. So that is why we prefer the liquid paraffin, because it can continue heating and provide the heat that the benzoic acid needs. In this lesson, however, someone pointed out that we must be also safety cautious. So if we notice that the paraffin we are supposed to use is flammable, that also will disqualify it. So we can argue out ourselves that provided the paraffin is not flammable, it is the best alternative there. I hope Beata, that answers your question.
Teacher Eva.
Excuse me, teacher.
Teacher Eva, just a moment. This
Yes,
was
teacher,
supposed to be liquid paraffin wax. Liquid paraffin wax has a very high melting point, so it is safe.
Okay, that is what we are saying, that if the learners, first let me emphasize, when you're choosing your liquid to heat, just check for safety, as someone has pointed out. On the packages, usually they indicate whether it's flammable or not. So if you find it's flammable, do not use it. If it's not flammable, that would be a good liquid for you to use. Okay?
Excuse me, teacher.
Yes.
I wanted to ask about number 2, that impurity is lower the melting point. So on number 1, part B, why do they say that a substance is impure and it melts over a wide range of temperature? That means that impure substance has a high melting point, and yet impurities lower melting point. So that is confusing me.
Okay, I'll clear that quickly. A wide range means that when we say a pure substance melts at a fixed temperature, you'll find it will start melting at 0 degrees Celsius. And even as you give heat to the mixture, to the substance, the temperature stays reading 0 until it has all melted. But when it is impure, you'll notice maybe that like at -5, it has started melting. As it melts, the temperature is continuing to increase, -4, -3, -2. So it's melting between -5 and 0. That is a wide range. It doesn't mean that wide is above. I hope that clarifies it.
And maybe lastly,
last question.
Lastly, concerning the same, the more impurities you have, the wider the range. The fewer impurities you have, the smaller the range over which they melt.
Thank you. Then the last one was defining. These definitions we can get in our books.
Let them take a screenshot of this and they will do as homework.
And please inform your friends, because many have left the classroom. I see we are now 1:49
I'll
Sure,
post
but thank you for handing
We
over.
do this. Sure, should we do this in our books?
Yes,
Then
these
I
are
also have,
everyday experiences. If you finish
excuse
copying
me,
the
teacher.
questions, let me first make this communication. If you finish taking down these questions, girls, you're free to leave. The lesson has ended, but we can handle those questions of those who want to ask. We are sorry we've held you long. Okay? So you can ask the one asking.
Excuse me, teacher.
Yes, please.
So about the video that we watched, is it necessary to always have to find an average? Like she said, you have to record the temperature at which the substance started melting and where it stopped, then you find the average. Is it necessary to use that method?
Yes, in many experimental things that we do,